short video on just simplifying radicals. Let's take this one. The 3 outside of the radical is called the coefficient. We're just going to bring him down. We can't do anything to him now. He's a whole number. We're going to leave him be. Now, if I look at my list of all my perfect squares between 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on as I write them down, I like to make myself a little bit of a list of all of my perfect squares so I know what I'm using. And I generally stop about 121 or so, but it may be higher. Okay, now I have to figure out which number from my list of numbers perfectly goes into 72. You always want to start towards the top, and you should already think that 81 is too high, 64 is going to be too high. I'm pretty sure 49 is too high because 49 times 2 is 98. So let's try in our calculator 36. So if I type in 72, did I get 72? 72 divided by 36, I find it's perfect, it's 2. Okay, so I'm going to use that and break down 72 to radical 36 times radical 2. Now I know that radical 36 is rational and it's a perfect square, but I want to leave them both inside of the little root signs until I'm ready to use them. Again, 3 just follows down. Radical 36 is 6, and radical 2 is irrational, stays radical 2. I can't break down radical 2 further. Nothing from our list goes into radical 2. So always ask yourself at the end, does anything from my list go into this? If not, we're done. Since I have a 3 and a 6 with nothing in between them, no symbol, I'm going to multiply them, and my final answer is 18 radical 2. As far as variables go, if I have an even variable, like x to the 8th, then they're already rational, and I can pull him right out. He's a perfect square, so the square root of x to the 8th is x to the 4th. All I have to do is cut my exponent right in half. The square root of x to the 10th, or whatever letter variable I'm using, he's x to the 5th. Now, if the variable is odd, that is a little bit trickier. So if it's something like y to the 3rd, probably the best way to do this is to actually still simplify it, kind of like I did with the numbers here. I'm going to simplify y cubed to be y squared times y. And what I'm always doing is just subtracting 1 from whatever this exponent is, and that's where I got y squared from, because I need one of them to be perfect, and the other one's just y. I'll leave him in. Now the square root of y squared is perfect. He's just y, so he gets to come out. The square root of y is not, so it will stay in. Oh, bye.